If you've ever had one of those days with a stiff, painful neck, you know the feeling. Your first instinct is just stretch it out, right? And for years, a physical therapy treatment called cervical traction has done exactly that. The idea seems so simple, a gentle pull on the head to relieve that awful tension. But what if I told you that simple idea is completely wrong? Let's dive in and unravel this neck stretch mystery. And this, right here, is the question at the very heart of our story. Because the answer, according to the science, is, well, it's not what you'd expect at all. It's a story that starts with something everyone just assumed was true, gets totally flipped on its head by a baffling discovery, and is finally solved decades later. So, to really get this mystery, we first have to understand the conventional wisdom. Why do we even stretch the neck in the first place? What's the thinking here? At the center of it all is this treatment called cervical traction. Now, this can be done by a therapist's hands or with a special machine, but the goal is always the same. Create a little bit of space by gently pulling your head away from your shoulders. And the logic? It seems flawless, doesn't it? Your neck hurts, so the muscles must be tight and spasming. So you stretch those muscles, they chill out, the pressure comes off, and poof, the pain goes away. It's intuitive, it makes perfect sense. And for the longest time, it's what pretty much everyone believed was happening. But here's the thing about science. Even the most obvious, common-sense ideas have to be put to the test. And when researchers decided to actually test this one, they stumbled onto a genuine medical mystery. Okay, so let's go back in time. The year is 1991. A study led by Mary Murphy sets out to prove what everybody already knew. The hypothesis was super simple. When we apply traction, the electrical activity in the neck muscles, which is a direct way to measure how much they're firing, should go down. So they hooked patients up to these EMG machines to watch it all happen in real time. Now, the researchers fully expected to see one thing. They thought that after they applied the traction, these bars on the chart, which represent muscle activity, would get smaller. That would have been the proof they were looking for. Traction equals muscle relaxation. But that is not what they found.
Instead, they found the complete opposite. It was a truly shocking result. And I'm quoting directly from the paper here. The present data show a substantial increase following traction. The muscles weren't relaxing. They were firing up even more.
And this created a massive paradox. You have the objective data from the machines saying the muscles are actually getting more active, more tense, but then you have the patients themselves, and they're reporting significant pain relief, sometimes for up to 12 hours after a single session. This left everybody scratching their heads with one baffling question. How is that even possible? If the very thing we thought was making people better, muscle relaxation, was actually doing the reverse, what on earth was causing the pain relief? And this puzzle just sat there in the scientific literature for over 30 years.
All right, now let's fast forward to 2026. A brand new team of researchers decided to take another crack at this old mystery, but they came at it with a totally new idea. They thought, maybe the answer isn't if you stretch, but how much. So this new study, led by Jellad and his colleagues, shifted the whole focus. Instead of just looking at the muscles, they started asking about the force being applied. They wondered if there was a dose-response relationship. In other words, does changing the amount of pull actually change the outcome? So they set up this brilliant experiment. They split patients into 3 groups. Group A got a teeny tiny 2-kilogram pull. That's basically a placebo, not enough to do much. Group B got a medium 8-kilogram pull, which was meant to stretch those surface muscles along the spine. And then Group C, they got the heavy-duty 12-kilogram pull, designed to get way down deep and target the facet joints and the discs themselves.
And here's the really crucial part. They measured way more than just muscle activity. They looked at that radiating nerve pain that shoots down your arm. They measured balance and dizziness. They even tracked psychological things like depression and anxiety, because they knew that chronic pain affects the whole person. So after 12 sessions and months of follow-up, the data came pouring in, and the answer was just unambiguous. That heavy-duty 12-kilogram dose was the hands-down winner, and not just for pain. So first, let's talk about that radiating nerve pain. The 12-kilogram group showed what scientists call a statistically significant improvement compared to the other groups. What that really means is the result was almost certainly not due to random chance. This was a real effect, and it was our first major clue.
But, okay, this is where it gets really fascinating. They measured something called postural sway, which is a key way to measure your balance and dizziness. And you can see it right here. The 12-kiddy group
had a huge, significant improvement in their balance. The other groups, they just didn't get that same benefit.
They even found some pretty amazing unexpected benefits. When they looked at depression scores, guess what? The high-dose group again showed way better outcomes than the placebo group. Getting the right dose of traction wasn't just helping their necks, it was actually improving their mental well-being.
So what does all this new data tell us? Well, it allows us to finally go back and solve that 1991 mystery. It's led to a completely new understanding of what's really going on when we stretch the neck.
The big, critical takeaway is this: cervical traction doesn't seem to work by relaxing muscles at all. It works by creating physical space inside the spinal column. Let's break down this new model. That heavy 12 kg force is strong enough to physically widen the spaces between your vertebrae. This, in turn, reduces the squeeze on irritated nerve roots, which is exactly why that radiating pain gets better. And when those nerves can function properly again, your brain gets much clearer signals about where your head is in space. This improves something called proprioception, and that's what reduces that feeling of dizziness. So that muscle tension the 1991 study saw, it was probably just the muscles reacting to the strong pull. It was a side effect, not the main event. So at the end of the day, that original 1991 study wasn't wrong at all. In fact, it was incredibly important. By showing that the simple, intuitive theory was incorrect, it created this fascinating paradox that forced scientists to dig deeper, to ask better questions, and ultimately to uncover the true, more complex reason it works.
And that leaves us with a final thought, doesn't it? This whole story is a powerful reminder that in medicine, the simplest explanation isn't always the right one. It really makes you wonder, what other common treatments that we just take for granted might have a much more surprising and complex story just waiting to be uncovered?